Welcome to Secure Design Patterns for a Serverless World. My name is Gokul Raghuraman, and I'm a director in PwC focused on helping customers like you build and operate cloud solutions in a secure manner. I'm very excited to be here today, and for the next 30 minutes, we are going to be talking about two topics that repeatedly come up in our client conversations: how to build serverless applications, and how do you ensure that the applications are secure on the cloud. As we work with our clients in a number of industries, and as we help them adopt and transform in the cloud, we see that the application teams and the product development teams invariably wanting to leverage a lot of these platform capabilities or these managed capabilities that AWS and other cloud providers are making available to them, right? And we are not at all surprised by that. Given the rapid pace of innovation that's happening in the space, we understand why the application teams see merit in wanting to play around with all these and leverage all these services. Clearly, no one wants to spend time on worrying about the plumbing that is required to stand up the infrastructure and maintain it, instead of focusing on the application and the business logic that is required to actually run the business and making those capabilities and features available to the users as quickly as possible, right? Which is great, but speed to market alone is just one side of the coin, right? While helping your business teams and users is great, um, you don't want to let down the guardrails that you need to put in place to ensure the stability and the security of your application. So the trick is, how do you find the right balance in delivering the features in an accelerated manner for your users, at the same time ensuring the right security posture is in place, right? In the next 30 minutes or so, I'm going to walk through some of those critical security foundations that are necessary as you start thinking about how do you design those applications and make them run on the cloud in a secure manner, right? Now, we are not going to do a deep dive in every single area, but I'm going to give you just enough considerations for you to, have in mind as you start making the architectural decisions that you require to leverage serverless on the cloud, right? So why don't we just dive in? Um, let's start with a typical environment, not too uncommon, that we see in our clients on a day-to-day basis, leveraging traditional application architectures that they've been running for a long period of time on their on-premise environment. Right now, this application is probably using a legacy monolithic kind of an architecture. There's a lot of dependencies on the underlying infrastructure. There's a number of subsystems and application that it relies on, making change to your application very tedious, and it probably takes months, if not weeks, to release and ship features, right? Uh, your application is probably tightly coupled, making it very difficult to isolate failures and deal with them in a consistent and a streamlined manner. To make matters worse, there's some sort of an industry change or a regulation that you have to deal with on an ongoing basis, right? So these are all pain points and challenges that almost every enterprise faces, whether you are in financial services or whether you are in healthcare. These are challenges that any enterprise application developer faces. We've seen the industry move towards a more microservice based architecture to solve a lot of these problems, right? And rightly so. Clearly, a well thought out design helps ease out a lot of these pain points, and there are several public case studies and even blogs that support the value of adopting this approach. And it makes sense. And what makes it even more interesting is that cloud providers like AWS make it all the more easier to implement these microservice based design patterns in a very simplistic manner by providing a lot of native services and capabilities that can help you as an application developer build your application that can independently operate and scale, isolate the failures, and make it easier to focus on the application logic of running these services, right? Now, given this environment and this scenario, and the advent of microservices and the availability of cloud native services, where do you start? What do you need to do in order to take advantage of these services, but at the same time ensure that security is baked in right from the beginning, right? So why don't we take a look at some of the design considerations that you have to think about as an application team or a developer. Now, as you start looking to architect or re-architect rather your current application to run in a cloud native or a cloud optimized world, there are primarily four um, considerations for you, right? One, how do you optimize your application to take advantage of the capabilities and the heavy lifting that the cloud can offer? This means relying on your cloud services more and more to manage the infrastructural aspects of your application and reducing the operational overhead of maintaining them. Design the application in such a way that you can reuse these patterns at a later date, and you've created the pattern to be built in a consistent manner and easier to reuse across your enterprise, right? So that's the first thing as you start thinking about these leveraging microservices in a cloud native world. How do you make sure that security is baked in right from day one and is not an afterthought only when you need to go to an architectural or a security board review meeting to get the go ahead to deploy your application, right? We've seen this over and over again. That means that you have to start thinking about how is my application taking care of basic identity capabilities such as authentication and authorization. How do I protect the application both at rest and in transit? And how do you identify any kind of undesirable change that is happening in the environment or in the application data, right? So security has to be a day one priority. How do you make sure that once you had the security and the reusable aspect and the design aspect taken care of, you've decided to optimize your application, which is all great. Now you can benefit from the heavy lifting that the cloud services can now provide, but you still need to know which services to pick and the right use case for using each of those services, and what's the best practices and watch points to be aware of as you're using them in your application for your business resiliency expectations, right? AWS, as an example, provides more than 150 services. And every category, right from compute to serverless, has a number of capabilities and services, and the speed of innovation and that these services get enhanced wants to make you think carefully about putting in the right foundational principles that can then help you make those architectural decisions. We spoke about security, we spoke about resiliency. Now, how do you ensure that this application is doing what it's supposed to do? How do you know what's happening in each of those requests and all of those workloads that are happening, that are running in your environment, right? You need to be able to independently scale and offer protection from a failure perspective. So which means you need to have the ability to have full transparency, visibility, and traceability in your applications right from the start, right? So those would be the four, if you will, four large buckets of design considerations that you should look at as you start building your serverless application. And I didn't touch any of the underlying infrastructural capabilities and the network capabilities for a reason, because we'll talk through why some of those have been abstracted away from you and you have a certain responsibility as a developer to worry about first. Now that we know all this, these are the design considerations, where do we start? Now let's take the next few minutes to talk about what serverless design means, and how do you as an application developer have to think about it. So as you can see on this slide, we are going to talk about two things. I'm going to talk about the shared responsibility model in a serverless world, and then walk you through an example of a typical serverless architecture and the kind of design patterns and decisions that you'll have to make. I'm sure you've heard of the AWS shared responsibility model. If not, please go and take a look at that, because understanding that is foundational if you have to design the right guardrails in place, right? In a let us assume that for a minute that you're running in a normal infrastructure as service kind of an environment on AWS. In that kind of a server full environment, you are relying on infrastructure services from AWS. And it allows you to free up some of the operational overhead as AWS runs and manages the components from the host operating system down to the physical security of the facility where the service is actually operating in, right? Which means you as a developer had to take responsibility and management of the uh, guest operating system, whether you as your team manages it or you have like an IT infrastructure team which provides the capabilities to manage that, and any associated application software that you'll have to bake into your server, any configuration that AWS service provides, any kind of updates and security patches that you need to apply, right? Now, in a serverless environment, it gets even better. AWS manages the underlying infrastructure services as well as the operating system and the application platform. So, as an application developer or a team which is responsible for building out the solution, you are now left responsible for the security of your application code, the storage of the sensitive data that your application probably is using, the identity and access to the resources that you use in the environment, right? So let's take a look at this illustrative architecture using a number of serverless capabilities that I've used here as an example. We have some microservices exposed via the API gateway. The services talk to a data store. It could be, in this case, it's an RDS. It could be Aurora. It could be DynamoDB, some kind of a data store that it uses. Any events, requests, responses, logs get published into S3. And then all these services interact with each other using some kind of an event-based mechanism. They talk to each other using, in this case, AWS SQS and SNS. Right? Now, assume that there is some sensitive data also being passed around and stored across, accessed by all these services. In such a typical serverless architecture, how do you begin to secure the application footprint? This is probably one of the simplest use cases, but these services, if you start looking at serverless capabilities on AWS, you're definitely going to look at some kind of a microservice written on traditional Java, running on as a Lambda or running on a container, using some kind of a event-based mechanism like an SNS, SQS. So these are all common services. You're going to rely on some data store, right? Now, before you even start designing the security around these solutions, you should be aware of 5 key domains that you should focus on when you go down the path of serverless. Identity and access management, which is absolutely critical. The application code, the data the data that the application stores, any of the infrastructural networking capabilities that AWS provides that you still have to take care of, and getting visibility into the environment using logging and monitoring, right? Those are the 5 big domains that you have to focus on. So let's start with identity. This is perhaps the most critical component, if you will, to get right in your service or your application. If you want to authenticate users and applications, you are going to rely on some sort of a user directory or a database to validate those users, right? When you start developing in your sandbox or in your lower region, we have typically seen bad practices such as storing credentials in a config file or even in a database, right? If you're storing them in plain text, it's even worse, as it means that anyone with access to that config file or the database now has access to all the credentials. We've seen some advances there where we've seen teams try to hash the passwords when storing it, but even that is not good enough because a bad actor could use a number of techniques to very quickly unencrypt them, right? So what should you do? If you're relying on your cloud service providers, I would recommend looking at some kind of a implementation which relies on secure remote protocols, right? Which prevents the common attack vectors on identity stores. But you don't have to do the heavy lifting. A lot of it is already solved for. There are readily available serverless identity store services from third parties like Okta or Ping, or AWS has its own native service called Cognito, which will let you do that, right? The good thing is it'll these services not only handle the credential validation, but because they are serverless, they can really scale. This again lets you focus more time on what really matters, which is your business logic and building your application code and releasing your features rather than worrying about all the plumbing that needs to be put in place. Now, the third-party services that I mentioned are all industry standard. They provide all the right capabilities. If you want to rely primarily on AWS, like I said, Cognito provides those features, and they really have two capabilities. One is a user pool, which was the managed directory for your users, and it handles the user authentication. And two, it provides an identity pool, which handles all the permissions on AWS for that user. Along with centralizing the identity management, you should also look at centralizing your privilege management, right? This provides a much better security posture on top of your centralized identity store. And not only that, it gives you a much better customer experience or a user experience, because you don't want, as a developer or an application team, to remember multiple passwords, read them from multiple stores. Once you go down this path of a federated access, it gets even more easier. You're going to automatically be pushed towards using some kind of a role-based access control, which in this case is AWS IAM, instead of using those long-term credentials, which are a very common attack vector, right? So we spoke about identity. Why don't we get to the next layer, which is the application layer? When we speak about application functionality exposed as APIs, we have to talk about the use of an API gateway, because APIs are normally your primary right front and center, and they provide the access to your applications. I'm going to try to cover a few topics here that you should take care of when you're using the API gateway. AWS has its own version of API gateway called the AWS API gateway. So the first thing that you should be thinking about is, again, access control, right? You can do multiple things using the AWS API gateway. You can configure your own API keys. You can use multiple authorizers. You can use AWS IAM, use OpenID Connect provider, or you can integrate that API gateway with AWS's identity store, which is Cognito. So we've seen various use cases revolving around them. It depends on your particular use case, whether you want to go with a OpenID Connect provider or leverage an AWS Cognito or even a third-party provider, right? If you're using your native service, an AWS native service such as Cognito, after the user has authenticated, all the incoming requests are going to include the access tokens. If the API gateway is not aware of these tokens, it's going to forward them to your identity store, in this example Cognito, which will help you validate the tokens and give you an access policy, right? That is what is critical, and that tells you what permissions are then allowed for that incoming request, right? If you want even more fine-grained access control and you want to enforce least privilege in your applications, you will need to write some level of custom logic to be able to take care of that, right? So as an example, let us say you want to check whether the user, um, who's making the request, is part of a certain subscription plan. He has a certain level of licensing, and the access depends on that kind of a plan, right? So you will need to check on their subscription status, and based on that make a call, which is slightly more complex. And that's where something like a Lambda authorizer comes in. The idea is very similar. The tokens go to the Lambda authorizer in this case, and then you can then write custom business logic on how you want to authorize the request. You can check on things like the subscription plan, the status, and then plug in your rules to do whatever action you need to take. If you use the Lambda authorizer, you need to do two things. You need to check that the token is valid, and then you have to return a policy for every request. So we've seen two types of authorizers for API gateway, used for the access control. Now, we spoke about access control. There are two other techniques that I'll bring up. One is the concept of request or input validation, right? You should never trust any input as is before and send it off to your backend before validating it, right? API gateway provides you some basic request validations out of the box, like it'll let you check the parameters, the query strings, and see if they are not empty and things like that, right? It also has another capability where you can actually check whether the payload adheres to the schema request model in your method, right? Which is very important because it allows you to at least check whether the components of the request are similar to what your API is expecting. Now, these are some out-of-the-box capabilities, and these are basic validations, but these are by no means the only things that you should be validating. There's a whole bunch of design criteria that you can go look up, and you should be implementing as you do request validation. Another thing that you should be thinking about when using API gateway is the cross-origin resource sharing, or commonly known as CORS, right? Which is basically a mechanism that you need to implement in APIs to let browsers access them. Misconfiguring this access has bad implications, obviously, and it can result in data getting, stolen or compromised. Before going serverless, you had to manage this in your application code as a developer. But with Gateway, the API Gateway, there are some basic capabilities where you can mock the responses to the browser request, and you can configure the headers and the methods that are allowed to access your API. On top of using an API gateway, you should also consider leveraging a web application firewall. Not every use case demands this, but the good thing is, if you, depending on the kind of workload that you have, the web application firewall can be configured to listen for incoming traffic, perform the TLS handshake, and inspect traffic for the common threat vectors and rules, and it'll also let you load balance the traffic, right? It's almost like a knob that can be turned on and handles all the configurations for you, so you don't have to create the rules yourself. We spoke about identity, we spoke about application. Now let's talk about the data aspect of it. We spoke about APIs being the forefront of your application. When it comes to data, there's again three major things that I would recommend looking at, right? One is the right level of access to your data. Two is what kind of data does your application deal with, and do you have a way to classify the data and identify the data? And then three, encrypting the data at rest and in transit, right? You might be using one of the many data store options that AWS provides. It could be Dynamo, it could be Aurora, it could be RDS, but being able to control access to the data and provide just the amount of access required is critical. One of the most common use cases that we have seen is the ability to control access to data in a database at the row level, right? So when you have a specific use case around row level security, if you're using a serverless solution like a DynamoDB or even like a reporting solution like a QuickSight, which relies on the data, this is taken care out of the box for you, right? So I think knowing which services provide these capabilities is very critical as you assess what kind of a data store option that you have to pick. Obviously, you'll decide whether you need a relational database or a non-relational database, but on top of that, I think you need to look at column level security, row level security as these services provide and how to leverage them. Now let's move on to another layer of our application. S3 is a very popular service. We've seen application teams use S3 by default is private, right? So the data and the bucket itself is secured by default. But just like everything else, appropriate access sometimes is not given, and they are misconfigured, and they are one of the most common reasons for data leak. So I would absolutely look at a way to secure, put in those right guardrails to secure like data stores like S3. There are services available in AWS and even third-party services. AWS offers Macy, where you can identify usage of classified data in your environment, right? Beyond using these services, what's more important is you have a strategy and a framework in place to classify and tag the data. That is more important. Once you have solved for that, then you can use all these services to identify exposure. From an encryption standpoint, I think AWS, if you use all these serverless capabilities, I think data is by default encrypted in transit and at rest. You can leverage AWS KMS that will allow you to use the customer keys to encrypt and decrypt the data. There's a number of third-party solutions as well, like Gemalto, SafeNet provides very similar capabilities. If you have to encrypt any of the data stores, you can leverage that. So we spoke about data. Now let's talk a little bit about the infrastructural capabilities. And when we talk about infrastructure, I need to talk about application vulnerability, right? Just because you're running serverless applications, that doesn't mean that you're not exposed to common vulnerabilities. You are still vulnerable to things like DDoS attacks or cross-site scripting. If your API is using AWS API gateway, then you could reduce your attack surface because you don't need to expose the APIs to the public, and you can force your users to access the API via something like a CloudFront, right? Now, on top of what API Gateway and CloudFront offers, you should also consider something like an AWS Shield, which is again a managed service that is designed to protect you from these attacks. Depending on your use case, you have a choice to leverage. There's a standard option and there's a more advanced but expensive option. But I think you can do the due diligence to figure out which option you want to go with. But nevertheless, for public-facing websites, you should think about this service. Now, we spoke about all this. How do you ensure that you have full visibility into what's happening in the environment and you get alerted when something bad happens, right? So that's where AWS provides the log monitoring capabilities out of the box. CloudTrail and CloudWatch help you there. AWS config is the service that you can configure for predefined alerts for any changes in your environment baseline, and you can act on it, right? So we spoke about all these guardrails. What does success look like at the end of all this? You have designed all this in your application. We spoke about some of the design principles. So from that perspective, you've leveraged a lot of managed services. You have reduced your infrastructure overhead, and you focused on application business logic, leading to faster release cycles, right? You are able to ship features faster for your business and to your users. The managed services also provide you capabilities to manage and scale and be highly available out of the box, right? So if you pick the right service based on your SLAs, you have a good opportunity to manage your scale and availability in a streamlined manner. We spoke about the security capabilities previously that AWS offers, which will let you run this, have a good security posture in AWS. Now, if I have to summarize and talk about very quickly what are the key aspects, there are 5 domains we spoke about today. You need to start with a strong identity foundation and use a centralized directory service based on on a standard like an OAuth. You can pick Cognito, you can pick any of the third-party services, but go for a centralized service. You pick a centralized privilege management in AWS and eliminate the reliance on long-term credentials. Apply security at all layers and make sure that you have defense in depth, so the bad actors or attackers have to go through multiple checkpoints that we covered around access control, request validation, cross-site scripting, and don't trust your user. Right? So we covered DDoS, we covered AWS Shield if you need advanced protection. But at the end of all these capabilities that AWS provides, good secure coding practices is a fundamental requirement, and you as a developer are still responsible for that, right? While microservices and serverless capabilities help you scale applications better and release features faster, understand where your responsibilities lie and make sure that your application is secure. We also spoke about credential management and secrets management to make your application secure. Avoid storing secrets in your code or in your database, definitely not in plain text, and use a secrets manager, whether it's AWS or a third party, and get rid, or even better, get rid of that secret altogether, right? I hope you now have a few insights on considerations and design principles to keep in mind when building these serverless applications. If you have any questions or would like to interact with PwC, please head over to our sponsor page and you'll have a lot of information that will help you do so. Thank you again for joining today's session and enjoy the rest of the event. Thank you.